So here's some more examples for these simplify or trig identity type problems. The first one, we want to simplify tan x over cosecant of 90 minus x. And I arguably, to simplify, if you got something, you have 90 minus x's, you want to reduce those to x's if possible, just x's. So we notice cosecant of 90 minus x in the denominator. So the first thing I'm going to do is change this problem to be tan x times sine of 90 minus x in the numerator, because the reciprocal of cosecant is sine, so a cosecant in the denominator will send me to a sine in the numerator. And I then look at sine of 90 minus x, and the sine of 90 minus x is cosine x, so I've got tan x times my cofunction relationship is going to be cosine of x, and that's tangent is sine x over cosine x times cosine x. Cosines will cancel, so this expression equals sine of x. So again, a good strategy at times is to convert everything to sines and cosines, and some cancellation can occur. Cosecant would be a reciprocal of sine, so that's 1 over sine x, minus cotangent is cosine over sine, so that's going to give me a cosine squared x over sine x. I have a common denominator, so I've got 1 minus cosine squared x over sine x. And my Pythagorean relationship indicates that 1 minus cosine squared is sine squared, so I'm looking at sine squared x over sine x, which will simplify to sine x. So simplify sine x cosine x over 1 minus cosine squared. I notice that I've got a Pythagorean relationship in the denominator, which is going to give me a sine squared x, and I've got a sine x cosine x in the numerator, which is then going to have me cancel one of those two signs, so I'm left with a cosine x over sine x, and I could leave that as is or write it as one single trig identity, or one single trig expression tan x. So what I'm looking at here, I see a secant squared and a tan squared, and as the first two expressions, another simplified problem. And I remember that 1 plus tan squared x equals secant squared x. And so I'm looking at perhaps replacing one of these two expressions with something from up here. And let's see, secant squared would be 1 plus tan squared, and then I see a minus tan squared, so that's going to get rid of some stuff. So 1, let's see, secant squared is 1 plus tan squared, so 1 plus tan squared beta minus tan squared beta plus cotan squared beta. I will have the tan squareds disappear. I'm at 1 plus cotan squared beta. And I remember my other, one of my three other Pythagorean relationships, that 1 plus cotan squared beta equals cosecant squared, so I'm looking at cosecant squared beta would be my simplified answer. So this is a different type of problem. Express cotangent theta in terms of sine theta. So cotan theta, first of all, I know is cosine of theta over sine theta. So the denominator here looks pretty, the denominator looks pretty good. It's in terms of sine theta. So I've got to figure out how can I write cosine theta in terms of sine theta. And what I can remember is my Pythagorean relationship that sine squared theta plus cosine squared theta equals 1. So if I want to solve that for cosine theta equals plus or minus the square root of 1 minus sine squared theta. So I'll replace that numerator over here with plus or minus the square root of 1 minus sine squared theta all over sine theta. Now, how am I going to know about what this plus or minus is? Well, I'd have to figure out what quadrant my angle is in here, and I know my cotan. If I know what quadrant is in, I'll know if my cotangent is positive or negative, and that will allow me to decide what I'm going to do here in the end. I could use a reference angle and then figure out the positive or negative as my last step. So again, we said one of our strategies is to kind of just go ahead at times and just convert everything into sines and cosines, and I can do that But I also might want to take a look and see if, for example, multiplying out might give me something that's simplified pretty quickly. And looking at this, tan squared, but then tan times cotan, those are reciprocals, that's 1. So I'm seeing here then I've got a tan squared a plus 1. And guess what? My Pythagorean relationship is indeed 1 plus tan squared equals secant squared. And I'm done. So, again, we can look at taking and turning everything into sines and cosines and trying to simplify one side and make it look like the other side. I want to look at this. I'm already in sines and cosines. And I've got a cosine squared on each side. So if I remember my Pythagorean identity that sine squared plus cosine squared equals 1, I can replace this sine squared with 1 minus cosine squared, and when I do that I'm going to generate the left side. So again, cosine squared of theta minus, replace that sine squared with 1 minus cosine squared of theta. Does that equal question mark, this other side? Cosine squared theta minus 1 plus cosine squared theta. Does that equal 2 cosine squared minus 1? 2 cosine squared theta minus 1 equals 2 cosine squared theta minus 1. And I'm done. Now, could I have worked back up here instead of replacing this sine squared with a 1 minus cosine squared? Could have I worked here on the other side, perhaps, replacing this cosine squared with what it's equal to in terms of sine squared 1 minus sine squared, and worked back and gotten this side? Perhaps, and I'll leave you to think about that. So here's last example, last sample problem. Sine theta for cosecant plus cosine over secant equals sine theta cosecant theta. And both, certainly I would say arguably maybe the left side looks a little more complicated. But as complicated as this looks, it simplifies up pretty simply. Take a look at what you've got on the left side. You've got a sine and then cosecant in the denominator, which is going to reciprocate that cosecant to turn you into a sine squared. And ditto with the secant cosecant. Secant comes up into the numerator, it becomes a cosine, reciprocal relation. So you've got cosine squared theta. And sine squared theta plus cosine squared theta is 1. So how about on the other side? Yeah, sine and cosecant are reciprocal relationships. So you got sine theta over cosecant in the numerator means you got a 1 over sine overall. So sine theta over sine theta, and that simplifies to 1. So again, I've turned the left side into an expression, simplified it, turned the right side into the same expression. If you can turn the left side and the right side into the same value, then by transitive property, the two original expressions are equal.